Hi, Chem students. Hope you all had a good weekend. Thought we'd start our week off here with a little humor. So if you don't already have your calculator, you want to grab that. So today we're going to focus on looking at how we use instruments to measure pressure. Several you're already familiar with. Gauge that you'd see on a helium balloon tank. Tire pressure gauge for your vehicle or bike. You might have a weather barometer in your kitchen, and our focus today is going to be on reading what we call a manometer. So there are two types of manometers, a closed manometer and an open manometer. We're going to start with the closed manometer because that is so very simple to read. So manometers are essentially U-shaped glass tubing that are filled with mercury. So a closed manometer as well as an open manometer, they're going to extend this glass tubing here and allow us to attach a container of gas, and then there is a valve here. In a closed manometer, what is done is after we have our mercury in our U-shaped tube, if it's open here it would be equal on both sides, they're going to remove all the air above the mercury on this column and then seal it shut. That's what makes it a closed manometer. This end of the glass tubing is sealed shut. So now, since we have no air above that mercury, the only thing that will press on the mercury when we open the valve is the gas in this container. So now let's erase and open our valve here. You can see that the gas will now push on the column of mercury, causing the mercury to go up into this arm. So now if we want to know how hard it pushed, it would be that height there. And we simply record that, and we have read the pressure within the closed manometer. So let's look at an example with a manometer that looks a little better than what I drew. Okay, so in this drawing we can see that it is a closed manometer because when we look at the top of the column here we can see that it is sealed off. That's how we know it's closed. So if someone simply wanted to know what was the pressure of the gas sample that we see here, you would look at the difference in the two heights of the mercury, and we would see that it is 195 millimeters of mercury. So the pressure of the gas, very easily, just 195 millimeters of mercury, because millimeters of mercury is a pressure unit. So the only way a closed manometer problem can be difficult as all is if someone says, hey, I want you to use that manometer that only measures millimeters of mercury, and I want to know what the pressure is in kPa, full conversion. So all that we would do would be take our 195 millimeters of mercury, pressure conversion like we looked at our last lesson. I've recopied up here helpful conversion factors, so we want to use the 101.3 kPa and 760 millimeters of mercury. We want millimeters of mercury in the denominator, so our units cancel. The 101.3 kPa up top. We get our calculators out, and I got 26.8 kPa.